So, and that should be going. All right, good. So today is the first day of a new unit. If y'all don't mind doing, thank you. Okay, let's get this on both screens. So the new unit is called variables, conditionals, and functions. We've done some function work before, and on my short list of 4 or 5 major concepts in computer science, these are 3 of them. Okay. So this is important. Obviously, over the course of only, I don't know, 10 lessons or so, it's barely an introduction, but that's the case. So first step is I want to make sure everyone knows how to get back to old units if you need to work on things from the past. So right now, for whichever period you're in, its current unit is the one that we just did. And as I assign unit 4 to you, it should update to variables, conditions, conditionals, and functional functions, which is right here. Okay. And so the way you get back, if you forget, is by inside of your box. I know you only have probably one of these, is go to the full year curriculum and uh, go to unit 3 in 23-24 is the one we just came from. Okay. So the unit itself is broken up into 3 sections: variables, conditionals, functions. And for each one, it's this pattern of explore, investigate, of course, uh, this 4-lesson cycle of the topic of, whichever of the 3 topics. I don't know why it should be minimizing more, but either way, first one is variables, right? Variables are going to be with us the rest of the time. Like I said, they are a major computer science concept, and almost nothing is possible without them. Essentially, the basic stuff we've done so far, we've done without variables, even though we sort of have been doing variables with the loops and stuff. Those are sort of built-in variables. But please do listen. The analogy I always use for a variable is that it's a container. It's a box. For some reason, I always visualize a box like a shoebox. It is a box that can hold something. Okay. It can hold almost anything. And there are 3 things or so you can do with it. You can create a box, you can change what's in the box, and you can check what's in the box. Everything's going to fall into one of those categories, but there are a few rules in order for making it work, in order to make it work. And we are going to watch, if you are watching this on the replay, the videos aren't going to show up for the next minute or so, or next, I don't know, 8 minutes total. The videos we are going to watch are these 2, variable video 1 and 2. So, oh wait, did I stop sharing? No, I'm still sharing. So if that's where you are, that is the deal. So let's go ahead and watch those. Is it this one? Yeah. Okay. So yeah, for real, screens away, headphones away, all that good stuff. Please be sound.
Most apps keep track of pieces of information that change and update as you use the app. For example, a simple game can keep track of your score and the number of lives you have left as you play. Apps utilize the computer's memory, and learning how to use that memory when programming is a really powerful skill. The most common way to leverage a computer's memory is by creating a variable. Now, a variable is just a container for storing a value. And once created, The variable is stored in the computer's memory, and it can be used and updated repeatedly throughout the program. As an example, let's use variables to keep track of the score and the number of lives remaining in a hypothetical. Creating the variable is really easy. You use the word var followed by a label that you want to give the variable. You can choose any label you want, but it helps to choose a word that describes the variable that you want to store. So let's label our first variable score to keep track of the score. And then we can create a second variable to keep track of lives. Remember these labels. You'll need them later in order to use the variable. We can assign a value to the variable using an equal sign, like this. Let's set our starting score to 0 and our number of lives to 1. Remember, you only need to use the var at the time that you want to create a new variable. A common mistake is to use it every single time you want to refer to a variable. Also, be sure to avoid mixing up the order when you call it a variable. The label's got to appear on the left, and the value has to appear on the right, like this, not like this. Often, you'll want to create a variable and assign it a value the right way. There's a really convenient way to do this with one line of code. This is sometimes called initializing. It's important to realize that this single line of code is actually doing two things. First, creating the variable, and then second, assigning its value. Let's take a moment to talk about the equal sign. In many coding language, the equal symbol is called the assignment operator because you use it to assign a value to a variable. And you're probably used to seeing it in math, but in programming, it's a little bit different. If you were in math and you saw this, something would definitely be. Score can't possibly equal both 5 and 7, but this is not math class. With code, a computer is executing a set of instructions, one after the other. So this would just tell the computer to set score to 5, and then on the next line, set it to 7. In an effort to avoid confusion, programmers often don't use the word equal when we see this sign. Instead, they use the phrase gets the value. So when we see a statement like this, we could read it as score gets the value 7, or score gets 7. Some programming languages avoid the confusion entirely by representing the assignment statements with a side arrow, like this. To use a variable, you just refer to it by its label. Anywhere the variable name appears in the program, the value currently stored in the variable will be retrieved from memory. The tricky part is that when using a variable, you often can't see visually what its value is. To bypass that problem, you can use write or console.log to display it like this. This is a really handy trick, but remember there's a difference between showing the value of a variable and writing out the variable's label. When text appears in quotes, you're telling the computer to write those literal ASCII characters on the screen like this. But on the other hand, without quotes, the computer assumes that you're referring to a variable called score, and it will attempt to retrieve its value. If you haven't made that variable, then the computer will give an error.
More that's even shorter.
In the first variables video, we learned how to create a variable, assign it a value, and then use it in a program. Now let's add some complexity. One of the most powerful things that you can do in a programming language is use variables in expressions. For example, var new score equals score plus 100. With this code, we're creating a new variable called new score, but we're not just assigning it a number like we have in the past. To calculate the value of our new variable, the computer must first retrieve the value of the variable score from memory, and then add 100. The resulting number is the value of new score. What if we want to create a game where we increase the user's current score by 1 point every time a point is applied? We could do this by updating the value stored inside the variable score based on its current value, like this. This line of code can be read as score gets the current value of score plus 1. So if the current score is 7 and the user requires a coin, the computer must retrieve the current value of the score, which is 7, add 1 to it, making 8, and then store the new values back in the memory. Similarly, in our game, if the player does something bad, we might want to reduce the number of lives by. So that code would look like this. Lives equals lives minus 1, or lives gets lives minus 1. This process of updating a variable is called variable reassign. Understanding how variables are set and updated is a powerful key that unlocks many insights in the program. All good programmers can look at a piece of code and use what they know to trace the logic. Let's try with an example that's sometimes a little bit tricky to newcomers. Check out this video. In the first 2 lines, you can see that we have created 2 new variables, A and a B, and assigned them both initial values of 2. In the next 2 lines, we've updated their values so that they each get the value of A plus B. At first glance, you might think that A and B are both going to end up the same, but they won't. The key is to recognize that the value of A is being updated on the line just before B is changed. So what's being computed will change as well. Let's trace it out. When A gets A plus B, this will take the current values of A and B and add them together. The result of the equation is stored in the value of A. So as soon as this line of code is run, the value of A is changed to 4. With the next line of code, B gets A plus B. The sum of A plus B is now 6. This new number gets stored in the value of B, so the final outcome of the code looks like this. Variables are an extremely powerful tool in computer programming. By using variables, you can harness the power of your computer's memory to dynamically track important information while your program is running. Now let's get started.
Okay, jump into current unit and let's see if we go like this and put this up on the back. Okay, and double check audio. All right, so jumping right into the new current unit, variables, conditionals, and functions. Okay, so just like most of the units, lesson 1 is sort of, I don't even know if I'd call it an introduction. Some examples. Don't worry about the pre-unit pulse short answer. They are just sort of activation questions about your past experience with apps. And I actually don't really see the value in these explore apps because they don't, or the explore samples, they don't give you the code to see what's going on. Okay. I suppose you are supposed to like experience it and think about the things that change, as in um what needs to be kept in a variable and that sort of thing. These are the types of apps that we will be learning with, but at this point, it's just showing you some examples of apps. This one does use something other than numbers. It's using strings and it's concatenating, which will show some concatenation shortly. And I think we actually make something similar to this. And the last one is a checks for understanding. So we are going to go over this because this is a type of question that will be on the AP exam. Okay, so this format of code is called pseudocode. And it is just sort of a generic way of writing program code. And the reason why it exists is because, that's not what I want, because, please still be recording. Yeah, okay. People are familiar with different programming languages. And to be able to write something out that anybody who has a programming background can understand, regardless of their language experience, is useful. And that's actually the case for the AP exam also, where the full course is designed to be taught with any of several different programming languages. Code.org is not the only organization that creates curriculum for this, for the AP class. And on the AP exam, the programming questions are going to be in pseudocode. So you do need to be familiar with it. And there's a hassle later on when we get to lists or arrays where they count from 1 instead of 0 like every other language, but more on that later. So here, basically, there are definitely going to be questions where they give you some variables and you need to come up, or give you some program code, and you have to say what is the final value of this variable after the program runs. The easiest way to do this, and we'll be doing this several times, not today, but this type of thing, the easiest way to do it is to get a pencil and paper and keep track of the changes as it goes. Okay, so let's say we have a variable score, okay, on the first line. The next line, score gets 3. So now score is 3. On the next line, score gets the previous value of score plus 1. So it's 3 plus 1. Score's value is now 4. The fact that it used to be 3 is completely irrelevant at this point. Well, after this line runs, score just is 4. That's it. Then on the last line, score gets this string, this set of words, the score is colon space, plus the previous value of score. Now, this is a hugely important concept that, again, we will spend plenty of time on. This plus sign is not addition. This plus sign is concatenation. What that means is whenever you want to connect strings or strings with the value of a variable, that sort of thing, you use the addition symbol, but it's not addition like arithmetic. It's addition like connecting trains of a train car. You are just connecting the next thing and the next thing and the next thing, followed by. Anytime you have addition or the addition symbol, or one of them is a string, meaning words in quotes, that's what it's going to be. Now, if both of these variables were numbers and you did addition, it would work like addition. But either way, the previous value of score was 4, or the current at this point. So it's going to be the score is 4 is the final value of this, which they haven't really even talked about concatenating yet, but they have no problem throwing you in and hoping for the best. All right, so let's go on to lesson 2, which is the majority of this. And which one is this? Which one is this? Okay, lesson 2, bubble 1 and 2, or bubble 1, obviously, to start. Oh, did I not unlock it for this class? I thought I did. Lesson 2, hit refresh. I just unlocked it. That's fine. And all right, so this app, this thermostat app, we will be spending a fair amount of time with, at least on this lesson, but also later on, because there's a lot of good ideas here with this concept of incrementing or decrementing. Changing something, go up by 1 is a very common issue or technique, whatever, of programming. And that's all this is. Okay. Let's go ahead and look at bubble 2, and we can actually explore it. Make sure I have a fresh version of this. And all right, so let's take a look at what we have in terms of program code, or just in general. Let's just run it and see what happens. Okay, it looks like it's the same as the last bubble, so it works, which means we don't really need to do any debugging. Let's see what we're supposed to do. All right, so they want us to make a watcher for the variable named temp. This is where the watchers go, and a watcher in App Lab is the only place I've ever seen it, is useful as a way of keeping track of a variable as a program runs. It's just down here, you type the name in there. Hopefully everyone can see it. It's only in App Lab. In for real programming, you would probably have a console.log message as a way of having some sort of output. I showed that in the video, where if you have an app where you're in the middle of programming and you don't have any output yet, you don't have anything to the screen. Obviously, we are given an app with an output already built in and programmed to send stuff to. But as you're programming, and a lot of times things in your programs don't have any direct output, to keep track of them, you would use a console.log statement and console log the value of, or console log that variable so that it prints to the debug console every time it happens. Now, in order for us to keep track of temp, since the up button and the down button are both changing temp, we would need one in both places. But at this point, we'll just stick with the watcher. Okay. So we have two variables here. Variables are, well, global variables. We'll talk about global and local. Most of ours are going to be global. It's just easier not to have to worry about it. They are going to go at the top of the program code. Always, always at the top of the program code, because they can't be used until they are created. They are declared at the top, and then you don't have to worry about sequence or whatever. Variables always go at the top. The organization of the rest is sort of for your own sake to make things easy to understand, but this is required to work. So we have one variable called temp, and it's being initialized with the number 70, the value 70, and another variable called temp_f, which is just an empty string. Now, it's still empty, but because it's a open close parentheses, it's an empty string. We're giving it the properties of a string, which we will talk about the specific properties of a string shortly, if not today. And we only have two event handlers, up button and down button, and they correspond to these. I guess these are images. Do they? Yeah, they're actually images, but they're working like buttons. And on each one, they are both, the first step they're doing is reassigning the value of temp. Temp is being changed to whatever it used to be, -1 for the down button. And for the up button, the value of temp is being updated to whatever it used to be, +1. It's getting itself +1. The temp_f variables are concatenating this new updated value of temp, followed by the train car of space capital F, and being, that is now a string, or it's always been a string, but that string is being stored in temp_f, and that is what's being used as the output, as the set text. Okay, if this looks foreign, confusing, that's fine. It will look better as you go. All right, so having a watcher down here is fine, but its usefulness is diminished because we do already have a user, a visible output. But either way, we've got a watcher for our variable called temp. Run the program. Okay, we've already looked through the program code to see what it is, and modify. Okay, right now your temperature changes by 1 degree when you click the button. Modify the temperature so it changes by 2 degrees. I'll give you, I mean, if this takes more than 30 seconds for you, then you need help with it. Okay, how are you going to make this so it goes up and down 2 degrees each time? That, yes. Is it not? Why is this not reading? It's not good. All right. Sorry, folks. We had a sorry. All right. Well, let's hope that's recording. Okay, so how are we going to do this? Well, instead of doing for each one, temp gets itself -1, we're going to get temp gets itself -2, and temp gets itself +2. And that should make everything go up and down by 2. Excellent. And let's see, what else do we have? Okay, so that's it for bubble 2. I think bubble 3 is a like something different, like a check for understanding or something. Yeah. Okay. So bubble 3 is a read through the code. And um, how do you think math.round works? We get a new command called math.round. And looking at its application or its use, how do you think it works? Speculate. All right, so let's take a look. Um, I don't know how you could not get what math.round is. It's a tool for rounding whatever is inside of its parentheses. Okay. As we get farther into any sort of the orange blocks, it is going to be significantly easier to switch to text mode to change things. It requires you to be careful, though, because if you delete the wrong bracket, curly bracket, square bracket, anything, it won't let you get back into text mode, which there's always version history. But anytime you have, let's get rid of like this thing, um, it's it doesn't know how to switch it back into blocks, so it's not going to let you. Sometimes Control Z works, sometimes it doesn't. Version history always works, but just be careful is all the point. Okay, so we need to make watchers for temp F, which temp F is now the number for Fahrenheit. Temp C is the rounded result of whatever temp F is, -32 times 5/9, which is the conversion equation for Fahrenheit to centigrade. But, well, first, arithmetic in programming works the same as in algebra with order of operations. Everything inside of parentheses happens first, and so on, which hopefully you're familiar with. There isn't actually a ton of that in this, but understanding the concept of things that happen in parentheses are sort of protected is useful. Then also this math.round command, which you'll find that some of the commands can't just exist on their own. Like you can drag a event handler into anywhere or a set text to anywhere. You can't drag a math.round into empty space. It needs to go into a another block. Same thing with any of the arithmetic blocks. You can't really drag them in there. But where was I? Math.round. Okay, so no, that's not what I was talking about. Okay, temp C is the rounded result of this equation. And then temp display F and temp display C are just getting whatever the result of these values is, followed by um, a space and a capital letter, making them a string, like the words that are actually being printed out, which there's actually an easier way to do this without creating these other variables. You just have the text there. Don't worry about that for now. Okay. And right off the bat, before any clicking happens, because everything that's not in an event handler happens when you hit run, it happens on go. It's not waiting for an event. These two set texts are setting these. There's two text areas here. There is, let me change the background color and see if that helps show what's going on. There are, nope, that's border color. Let's go screen, screen. Where is the edge of the screen? There we go. And go like this. And okay, so yeah, you can kind of see that there are the actual text boxes are what's being set, what is using the set text. The set text, any of these set image, set text, set list, set whatever, are just different versions of the set property, which can be done for any of them. Either way, we're setting these displays to whatever the concatenation of the value of the temperature followed by the letter right away. But then you can see it's the same two lines of code. It's essentially just an update thing, which later on we'll be making our own functions just called update screen or something like that to collect everything, make it easier to call things later. But that is what's happening every time. Okay, these same four lines, updating the display variables, or actually they're all the same. They're updating the actual value, the number variables, and then the display variables, which are strings, and then actually setting those to the screen. And so what do we need? We need a watcher for each of these four variables. Okay. And let's hit run and see what happens. Do they all get updated? Well, let's speed it up. That's one issue. And are they actually updating? Is this all the debug console that I can get? There we go. Okay, so you can follow them updating on on the watchers list there. That's fine. Okay, math.round. So you can see that we are getting a whole number for the centigrade value, but that's not going to be the case when you're multiplying things by 5/9. So the reason why that's happening, you can guess, is the math.round command, which we are now going to get rid of for both of them. So you're going to go into, and this is by far the easiest way to do this, go into text mode and delete the words math.round. Now, math.round comes with its own set of parentheses, which in most design environments, in most text editors, when you put your cursor next to some bracket, it will sort of do like a highlight of its corresponding one, which you might not be able to see from this distance, but you should be able to see on your screen. And as you move it around, you can see like this curly bracket belongs to that, and this open bracket belongs to there, and so on. So that's important when you're deleting things to make sure you're deleting the corresponding ones. I did not delete the two parentheses for math.round because it doesn't really matter. You can stick things in parentheses and it still works fine. Now, technically, we should get rid of those the parentheses that came with math.round, which would leave you with this equation. Make sure you don't delete the last parentheses. Just go slow when you're figuring out which parentheses to delete. And there are a couple other math.rounds which we need to get rid of on lines 15 and 28. And hopefully it lets us go back to block mode. It does. Not hopefully. If there's no red squares on the side there, it'll be fine. And right off the bat, you can see that this first line of code or the second line of code is actually doing the arithmetic and presenting, or I guess printing the centigrade value there with all of its lovely repeating decimals. And I think you'll agree that having a rounded value, at least with regards to home thermostat temperatures, that's plenty of accuracy. And it's obviously a lot easier and more pleasant to read having the dot rounded thing there. And I think that's it for bubble 4. Let's look at 5. Eventually. All right, so we have the thermostat app now has a login screen, which all it does, it doesn't have any password checking checking aspect or username aspect to it. We will do that later. In fact, I think in the next one, but we will actually figure out the programming behind checking a username and password. I think in like lesson 5 or 6, not positive. This one is just expecting some form of text in the text input. And when you put something in there and go to log in, it gathers that text and puts it in this text output and takes whatever text you put in there, and that's when it shows up. There's also a home button, which I don't think is very clear that it's a button. I mean, clearly it's a home, it's a house, but this is just an aside about user interface design, where if it's not clear that this is clickable, maybe it's not the best. Regardless, we have an app that's the same as before, except it's now using a get text command in order to get and then print the text. Okay, let's take a look at how it actually works on bubble 6. Okay, and let me make sure I have the freshest version of this. Okay, read the code, new version of the app. So now we have the ability to get text. Okay, get text is exactly what it says. It takes the element ID that you want to get text from, and this isn't going to work right now, but let's say figure out this is called name input. We find the element called name input. And now we're starting to see how useful it is to have good, meaningful and descriptive names for elements. But name input and wherever we are getting it, which I guess we do already have a place where we're getting it on the login button. Login button is going and retrieving the text and putting it into wherever we have this command. This command is being replaced with whatever text is gotten from the user input when the login button is clicked. Okay. A lot of times we will put this in a variable just because it's easier to work with if it's in a variable rather than the entire block. But either way, this block is being replaced with, or it's going and getting the text and replacing the block with that text, which, because it's text being added to text, it's concatenated. Okay, this addition sign is not plus, it is and, I guess, or then. I don't know. There isn't really a corrected use of the plus sign, but it's connecting the train cars. Okay, this isn't addition. You can't add a string. Okay, remember, string is just a word in quotes. So what's actually happening is there is a variable called username which is the combination of the word hi and whatever text is there. And then that variable is what's getting set, being used to set text of the whatever it's called, text. Oh, we got to go to design mode and then home screen. Username text is the text area there. And I'm guessing it's, yeah, it looks like that. Right. So let's see what we actually have to do here. Investigate the code, new thermostat, what's changed. Get text. And we want to change this so that we can add an exclamation point after the name that gets typed in there. So let's take a look at this. So as an aside, the most common mistake students make in this at this time is using var more than once. Okay, if we have, let's do this like this, and we'll go var. Okay, having var tempf gets temp plus one will break it. We've already declared var, or we've already declared tempf up the top with var. You never use var again. Okay, this is just, like I said, an aside. This is the most common mistake, is using var a second time. The second most common mistake is messing up the order for concatenating strings with other things. So our goal is to add an exclamation mark after the user's name, which this is what's going to get the user's name. We need to concat a new train car on the end. And so how we're going to do that, we're going to do the plus symbol. And then it's the string, it's the character exclamation point. So it needs to be in quotes. Okay. This space plus space in between train cars, if you will, is only there to make it easier to read. This extra space doesn't actually change anything. But like I said before, the most common mistake is using var twice. The second most common mistake is messing up the quotes situation, where you're not actually like adding things, or you have the plus sign in the wrong place or the parentheses in the wrong place. It's just, I don't have any quick rules that will solve it every time. It's just about paying attention to every time you're adding a new car, it needs a plus sign, and the plus sign needs to be outside of the quotes. If you put the plus sign in quotes, it's not going to work. It's not going to work as the concatenating situation. And I got rid of one. There we go. Okay, so this is what our string or concatenation of a string, a get text command, which is whatever it's going to go and get whatever the user typed in that text input, followed by the string of just an exclamation point. So we look at it now and we hit run and we put somebody's name in there and we hit login, and now there's an exclamation point at the end. Let's see what else we need. Exclamation point, get text. I think that's it for this one. There was something else that we missed from an earlier one. I think it was from one of the other ones where we had to get rid of the space between the F at the beginning, but don't worry about that. I'm just recalling it now. All right, so that was it for this one. Let's take a look at the check for understanding. I believe lesson or bubble 7 is the check for understanding. And let's go like this. Okay, so explain your own words, the process of creating and updating a variable. How does the counter pattern with event work? So counter pattern just means, and I've never really called it that before, but this idea of a variable that updates, increases by 1 and increments by 1, taking whatever it used to be and adding 1 to it and reassigning it. It gets itself plus 1. is a super common paradigm, super common situation, and that is what you need to explain, but also creating and updating variables. So that is the extent of lesson 2. Let's hope this recorded.